bigger part. Okay, so before we get to the whole geometric probability thing, I'm going to quickly go back through general what probability is. Okay. So probability, guys, as you should kind of have a familiarity with it as probability being just a description of something happening. Usually, it's either given to you as odds, like you would think it in terms of a fraction, or a percentage. Okay. For your stuff today, I would assume, and I would want most of your guys' answers to be in terms of either a decimal or a percentage. Okay? Meaning like you'll get an answer that's either 0.16 or 16%. Like 0.16 is 16%. They're both the same thing if we're speaking probability. Make sure you guys have an understanding that if you get an answer today that's greater than 1, you screwed something up. Right? The probability can't be bigger than 1. Even 1 doesn't really make much sense if we're speaking about a real life event, unless it's something that's already happened. If you're trying to do predictions on something, which is normally where probabilities come into play, you want to predict something's going to happen. You're not going to have 100% likelihood it's going to happen unless you already know it happened. Okay? Either that or you're just doctoring up the predictability. All right, so when you guys did probability in the past, I'm sure you have at some point, but if not you remember it, it's a whole different thing. The basic idea for probability, and normally when they do this would be like, they can get a bag of marbles, you pick certain marbles out of the bag, that kind of thing. It's like a spinner, you spin it, probably it's going to land on the number 1 or something like that. The basic idea is you do the number of things that you want to happen divided by the total possible outcomes that something could happen. So if you got like the bag of marbles thing, I actually think that's the one example I have with this, the basic probability. So like your bag of marbles, the total number would be all the possible marbles that are in it. 12, all go in the box. All right. So the basic probability, guys, doesn't even change for what we're doing today. Okay, it's just looked at a little differently because we're dealing with area and perimeter, as opposed to just picking out things from the bag, things from the hat, random numbers, whatever. Okay. Now, since that doesn't change, okay, and part over whole is just a simpler way to write it, right? A percentage is always the part over whole. Probability is the same thing. So like I said, this would be a pretty basic probability question. Okay, we're saying you got a bag full of marbles, you're going to pick one randomly, you don't see what's in there, you just stick your hand in, you grab a marble. They've got certain numbers of each one, and saying what's the probability that you're going to pick a specific marble. All right, so in essence, it's just going down to you figuring out what part you're choosing from. So like in this case, if I was doing the one that has A next to it, the red, the part would be the number of red. Okay, so like this one here would be 3 over, how many total are there? 15. Okay, and that'd be fine. Like you can leave your answer that way. If you want to make it a percentage, that's fine too. If there was a problem like this. All right. If I was doing the green, how many greens are there? 5. So it's 5 out of 15. And how many blues? 7. So it's 7 out of 15. Okay. You could, like that's 1/3. Right. 1/5. Okay. Now your answers, like I said, guys, could be either fractions today. You could leave a percentage there. You could even, like for these answers here, if you wanted to do percent, you could put this could be 0.2. It could be 0.333. That could be 0.467. That's fine. But Okay, any of those would be acceptable answers. Okay, now, basically all we're doing is we're taking that idea, right, the part of a whole, like you would have done with this, and most people would be able to do this problem with no issues. And you're just going to apply the geometric aspect to it. Meaning, you can have perimeter, you have area, okay? Might choose something from a number line, all right? That's the only difference between them. Okay, so with everything that's up there, all right, if you want to rewrite the whole probability thing as a as more geared towards geometry, the part of the whole thing, if we're dealing with the number line of perimeter, the probability in terms of geometric aspect of number lines and perimeter is going to be you do the length of where you want the point to be divided by the entire length of whatever you're looking at. So if they say what's the probability that it's on segment CD and also on AB or something like that. Find the length of CD divided by the length of AB. Okay? If it's like when we get to area, it's probably going to be area. What's the area that, or probability that it lies in the shaded region? Find the area of the shaded region, just like we did yesterday, divided by total area. So what I was saying earlier is we're just taking the stuff we did yesterday and adding like one more step to it. Okay? So the problems are still going to be the same thing. It's still basically you practicing doing all of the area stuff, all the perimeter stuff. All right? It's just taking it and applying it in a different manner. All right? But the whole aspect is, if you get down the whole idea of probability is part over whole, percentages are always part over whole, then it's going to be hard to screw them up unless you completely screw up finding the area of something or the perimeter of something. Or like on a number line, you miscount the number line, so on. Okay? All right, so what we're going to do is I'm going to do just one quick problem in the number line. Okay, those should be the easiest ones. And then we're going to do some all the way to the area one. And just like yesterday, guys, I'm going to point out, there's going to be some times where you can do it much quicker than actually taking the time and finding areas. Like some of these problems are going to be fairly quick to do, where you don't have to waste time doing areas. Okay? So, first thing is number line. Okay, so you gotta look at the problem. This would be the way usually geometric probability is first introduced to you, because these are, or should be, fairly simple problems. The way these things are going to be worded, they're going to give you basically an entire structure. Like in this case, the entire structure is the number line, which is the segment AK. So say, I know a point's on that line. It's somewhere on that segment from A to K. I just want to know what's the probability that if it's on that entire number line, what's the probability it lies at each one of those smaller segments. Okay? Like the only way someone usually screws this up is they try and count for some reason and they screw up the count. Because most people, when they count, like if they count from, I've seen people count from like D to G, and from D to G, they'll count 4 instead of 3. Okay, because a lot of people, when they start counting, they start with the number 1. So what they would do is, if I just say count from D to G, a lot of people would go 1, 2, 3, 4. 4 points, but the lengthwise, when you count length, you always start with 0. Okay, so if you're going to do the counting thing here to get lengths, guys, just make sure you go 0, 1, 2, 3. All right? Much easier if you just subtract the numbers. All right, so if I started filling in the numbers here, let's see. If I did the first one, CH, how long is CH? Really? So, how long is CH? 5, right? So you can do the count, or just do 7 minus 2. Subtraction, and then the whole thing is 10. So your answer could be the 5 over 10, 1 over 2, 0.5, or 50%. Any of those would be acceptable. What if I did this one here? Is there an I or J? Yeah, so if we do from D to J, how long is DJ? What is it, 6? 6 over 10. So again, your set point is here, guys, 6 over 10. 3 out of 5, 0.6, or 60%. Those would all be okay. Okay, I wouldn't have any issues with any of them. All right? We'll just do one more. 11, 12, or 13, which one should I put an answer for? 12? Why?
19.
Why 12? Why?
Because it's easy.
Why is it easy though? It's 100%. Oh my gosh.
Oh.
It's 8K. If 8K is on it, you know. So it's already telling you it's on that line. You know it's already happened. That's the only way you're going to get on it. All right, so now this one should be easier. All right. So if we move into the area, okay, like I said, it's going to apply all this stuff. This was from yesterday, guys. All this stuff from yesterday. We're dealing with shaded regions, right? And shaded regions, I said you just take the area, and like 95% of the time, you're going to subtract the unshaded part to get the shaded regions, with the exception of a couple of problems. Okay? And what we're doing is now it's just going to take, and if we turn this into now a probability problem, where I say what's the probability that's in the shaded region if it's on the entire thing? This number is going to act as your numerator. That's going to act as your denominator. So if you're actually doing it this way, where you're subtracting the two numbers, you're going to have the two values you want to put into that fraction to get our probability. Okay? So just kind of keep that in mind as you're doing the problem. Now, I'm not going to have to do this on every single example I have of it. I mean, at least 2 of these I know we can do fairly quickly. All right? So that was from yesterday, because I'm not going to say that. Okay, so which one do you want to do first? Left or right? Left?
Bottom.
Bottom?
Can I start off with the side?
0% chance of that? What? Which one?
Left.
Left? Easy one?
Right.
The right? The harder one?
Yeah.
The left.
Oh my God.
Okay, we'll do the left one first. All right, now here's the thing. The reason I just said the left one is the easier one.
It's 4/5.
And guys, the way these are going to be worded, it's going to say, find the probability that a point somewhere in this entire shape also lies in that shaded part.
Wouldn't it be 80%?
Why is it 80%? There you go. This one's easy. Just 4/5. Right? We talked about it yesterday. I brought it up yesterday. I said, look, this is a regular polygon. All those triangles are the same. There's 4 of the 5 that are shaded in. 4/5 it. You can break it up into congruent parts, guys. These problems are much easier. Okay? So now, like this one over here, I can't do that because it's not broken up. All right, but if you can do ones like this, do it. Make your life easier. Don't worry about finding the actual shaded area and divide it by the total. Too much work. Okay? All right, so for this one over here, again, the question's going to say, I'm picking a point somewhere within that square. What's the probability that it's going to lie in that shaded region? So again, in terms of me doing a probability here, it's going to be the shaded divided by total, okay? And for me working with this, right, on this problem, I know the total area is a square, all right? And since the total area is a square, what is the area of that square? How would I find it?
13 squared.
13 times 13, which is,
169.
okay, so 169 square inches. Okay, now, the other one, so I know when I do my probability, guys, that number's going to be on the bottom. That's the denominator. All right, so shaded now, this is going to go back to how you would have done most of them, which, remember the shaded region, you just do the total minus the unshaded. All right, well, we already got the number for the total, so that part's done. The unshaded portion of that picture up there, that diagram, what are they? 4 circles. Are they all exactly the same? Okay. So this is going to be 4 circles. Area of a circle is pi r squared, correct?
Yes.
What's the radius of the circle? 3.25. What's half of 13?
6.5.
Okay. So again, the whole trick to these is make sure you figure out what the radius is. I kind of brought that up yesterday. So I know right now, like all that work I did is just to get the shaded area. So the total was 169. 4 circles was 4. It's pi 3.25 squared. All right, now here's the thing, guys. Since my answers need to be percentages, there's no point in leaving these in terms of pi. I want like a final decimal answer. So when you do the shaded, this all needs to be subtracted out. Like 169 minus 4 times 3.14 times 3.25 squared. That's everything? No?
You dropped something.
What? What is all this?
Okay, I'm figuring it out.
Come on.
Three.
Slow. On.
Stop.
36 point.
Great. Okay. All right, so here's the thing. That would be my shaded. And guys, the whole point of me having to do that for this problem was simply to get the number I'm going to put in the denominator. Okay, that was the part. That's where I wanted it to be. Okay, so when I get my final answer, the final answer on this one is going to be whatever 36.3 divided by 169 is. Okay, so if I divide those, it should get 0.215. So your final answer, guys, either needs to be that one or 21.5%. Okay, either one's fine. All right. You could leave it as a fraction if you, if like it actually came out to a fraction like this, where there are whole numbers on top, there's no rounding, law of numbers. Okay. All right, so I'm going to go through, let me do 2 more real quick. Okay, again, we'll do the one on the left first, because it's pretty easy. Or let me see if you can tell me. The one on the left here, do you think you could do that one fairly quickly?
Yeah. It'll be 1.
Yeah.
2/3.
It'll be 2/3? How do you get 2/3?
Because if you do the lines, there's 6 boxes and then 4 of them are shaded.
No. 4 of the 6 are shaded in, so 4 out of 6 would be it. So, and again, this would be 0.667, or that. Any of these would work fine. Okay? All right, so I just wanted to show you one more, just because, guys, honestly, you can break it up, break it up. Don't worry about doing the shaded areas. Like, if you don't realize that, you can still get around it by doing shaded regions, that's fine. It's just, it would take you long. Okay, last thing, I'll do this one over here, because it really doesn't take that long. Again, it's going to be worded as, I know a point somewhere on this big circle. What's the probability that it's going to lie in that shaded region? Okay, so again, it's gonna be probability equals shaded divided by total, right? And again, the total is a circle, right? Circle formula is pi r squared. What's the radius of that big circle there?
5.
5. So I know the total area is going to be 25 pi. All right, so I know that's going to be on the bottom. What is it, 74 pi? 78.5. Okay. Now for the shaded portion. All right, the shaded, the only things involved in this picture are two circles. So it's going to be total of shaded.
19.6.
So the total here, guys, or shaded is the total minus the small circle. What is the radius for the small circle?
2.5.
2.5, right? 2.5. So this is going to be 25 pi minus pi 2.5 squared. You said that is 78.5. Okay. Oh, let's make it the top. And then what's 25 pi? Alright, so those are the two numbers that they should be. Alright, so then you would just divide them out. 58.9 divided by 78.5. So the answer there, guys, is 0.75 or 75%. Which is what it would end up being if I kept it at 35. It's here, that's 78.5. A wrong number. You can double check it, but I'm going to figure out that. 25 pi minus the 2.5 is 30.5. What's that?
There were 78.5.
The area 25 pi. This is the total. All right. So that's it, guys.